Hello students, let us start the class. Today's is the last class as far as recording of the sessions is concerned, because we are dealing with the additional exercises which are present in each chapter, and this is the last set of additional exercises which is present in the module 5 for the cyclic course. In the module 4 there was no additional exercise written by me, because the procedure is same for any type of linear block coding. So you can work out the same exercises which are present in the notes. Now starting with the last set of exercises in the module 5, we have an exercise here now. A 15,5 linear cyclic code has g of x equals 1 plus x square plus x power 4 plus x power 5 plus x power 8 plus x power 10. I did not discuss about such exercises in the beginning there, because I wanted the students to understand the basic concepts. Now in the test or in the exam, you can expect exercises like this, where the generator polynomial can be of a bigger order or a higher order. You can see here, it is of the order of 10, so to say, or totally 11, so to say, considering the very first term also. So this is a 15,5 code, where n is 15, k is 5, means n minus k is 10, means the check bits are now 10, information bits are only 5. So using this generator polynomial, it is asked to draw the block diagram of the encoder circuit and the transmitter, and using the circuit to find the code for d of x equals 1 plus x square plus x power 4. So this is the data vector given, that also is given in the polynomial form. Now after writing the encoder circuit and after finding the code for the given data vector, verify the same using the polynomial division. That is the second part of this exercise. Now the third part of the exercise is check whether v of x equals 1 plus x power 4 plus x power 6 plus x power 8 plus x power 14 is a valid code vector or not. The vector given here, is it a valid code or not? Now as you can see, this generator polynomial is of much bigger order, and accordingly when we write the block diagram for the encoder circuit, the figure also will be much bigger. Procedure is the same, but the amount of polynomial order which we handle is larger. Let me show you the answer now. Given g of x is 1 plus x square plus x power 4 plus x power 5 plus x power 8 plus x power 10, for 15,5 code, g of x has to be of the degree 15 minus 5 equals 10, because n minus k is 10. So now we are seeing already it is up to the degree 10. Hence g0 is 1 here, because this 1 is present here. g1 is also 1, g2 is also 1, but g3 is 0. X cube term is not there. g4 is 1, g5 is 1, g6 and 7 are 0. You can see g6 and 7 are 0. And g8 is 1, g9 is 0, g10 is 1. So it is of the 10th order now. So now accordingly, using all these coefficients g0 till g10, we can write the diagram in this manner. You can see the diagram now. This is the circuit diagram of the encoder, where we have an enable signal here, then we have a data vector coming here, we have a switch here, single pole, double throw switch. For the initial clock cycles until the data vector is present, the switch will be connected to this portion, and later on for all the check bits, the switch will be connected to this portion, and for the next each clock cycle, the stored check bits are going to be transmitted through the switch to the channel. We have already seen this type of circuit earlier. The only difference is that this circuit is now much bigger compared to the previous circuits, because now the generator polynomial is of the order of 10. So we can see g0 by default will always be there, but G1 is also there, G2 is there, G4, G5 are there, and G8 is there. Here G3, G6, G7, G9, they are not there. So you can see here G3 is not there. Similarly, G6 and G7 are not there. Even G9 is not there. G10 by default it is there because of the connection to the XOR gate itself here. So as far as G0 and G10 are concerned, they have to be there as such. And other terms, there is connection done there, and for the coefficients which are having 0, connections are not done, where registers are directly connected in series. So you can see that way R0 is connected to the XOR gate, R1 is connected to the XOR gate, R2 is directly connected to R3, then again R4, then R5, R6, R7 are connected directly in series because G6 and G7 are 0. Again R8 is connected to R9 because G9 is 0. This is the encoder circuit. Now we will have to apply our d of x. D of x is now 1 plus x square plus x power 4. When we express it in the binary digits, it is 10101. D of x has to be of the order 5 now, right? It has to have 5 bits, not the order 5, it has to have 5 bits. So now 1 is there, x square is there, x power 4 is there, but x is not there, x cube is not there. So we have put 0 there. So it is 10101. This is a 5-bit data vector. Now using this circuit, we have to find out the code vector. Code vector contains the check bits as well as the data vector. For the first 5 clock cycles, 10101 only goes there, but in those first 5 clock cycles, that 10101 comes here also into the encoder circuit, and the check bits are formed there. Now for the next 10 clock cycles, whatever is stored in these registers is going to be output into the channel. So now the register contents initially are all 0, R0 till R9, there are totally 10 registers, it is 0. Then when reset is done, they are all 0. Later on in the next clock cycle, next 5 clock cycles, I am showing you this input is 10101 and the contents of these registers is in accordance with these XOR gates operations. So I will not go into the deeper details of the computation. In your free time, I want you to go through all these computations once again in detail. I have written the results directly here. Now using this 10101, we have these register contents. Now later on, for the next 10 clock cycles, the contents of the register are going to be output. So C of x is now, this R of x is 111000101. You can see the last line here. At the end of the 5th clock cycle, it is 111001001. That is the remainder polynomial as such when we go for a polynomial division. And d of x is 10101. This is going to be the code vector now. 111001001, This is going to be the complete code vector that is transmitted in the channel. Now we have generated this remainder bits or RFX using the circuit. Now in the exercise it is asked to verify this. So now let us verify. For verifying, we should have a polynomial division now. So to verify, x power n minus k into d of x has to be divided by g of x. Let us find out x power n minus k into d of x. That is x power 15 minus 5 into d of x is 1 plus x square plus x power 4. Now when we multiply that, x power 10 into 1 plus x square plus x power 4 is x power 10 plus x power 12 plus x power 14. So this is now x power n minus k into d of x. Now we will have to divide this with the generator polynomial given, that is g of x. G of x is 1 plus x square plus x power 4 plus x power 5 plus x power 8 plus x power 10. When we perform the division, at the end we get this remainder 1 plus x square plus x power 6 plus x power 9. That is the remainder polynomial. Anyhow, we are not going to use the quotient. Now this R of x is what? 1 is there, 1. X is there, 1. X square is there, 1. X cube, x power 4, x power 5 are not there, 0, 0, 0. X power 6 is there, 1. X power 7, x power 8 are not there, 0, 0. X power 9 is there, 1. So 1, 1, 1, 0, 0, 0, 1, 0, 0, 1. You can see 1, 1, 1, 0, 0, 0, 1, 0, 0, 1 is the remainder polynomial or the check bits which we obtained from the encoder circuit, and it is verified even using the division. Now thus the answer is verified by the division method. Now the third part is to find out whether the given vector is a valid code or not. The given code is what in the third part? The given code is 1 plus x power 4 plus x power 6 plus x power 8 plus x power 14, whether it is a valid code vector or not. So we will see that now. If the given vector is a valid code, that is 1 plus x power 4 plus x power 6 plus x power 8 plus x power 14, if it is a valid code, it has to be divisible by g of x. Now using g of x here, using the code vector given here, when we perform the polynomial division, we do not get 0 remainder. We were supposed to get 0 remainder, but we are getting one remainder here. Remainder polynomial is present here. We can express this remainder polynomial as 0, 1, 0, 1, 0, 0, 1, 1, 1, 1. We can express the same polynomial in terms of bits. Now it was supposed to be zeros only. When we are not getting all these zeros, it means the given code vector is not a valid code vector, it is having error there. So as the remainder is non-zero, the given v of x is not a valid code. In other words, it contains errors. This is the answer. Let us go to the second exercise now. The 15,7 cyclic code is generated by g of x equals 1 plus x power 4 plus x power 6 plus x power 7 plus x power 8. 15,7 means check bits are 8, data bits are 7. Generator polynomial is given here. It is asked, find the code vector in systematic form for d of x equals x square plus x cube plus x power 4. So here the data vector is 0, 0, 1, 1, 1, right? 1 plus x is there, is not there. So it is 0, 0. Then x square is there, x cube is there, x power 4 is there. So it is 0, 0, 1, 1, 1. But it has to be 7 bits. So it has to be 0, 0 next. 0, 0, 1, 1, 1, 0, 0 is the data vector. Now, given by d of x. We have to find out the code vector for the data vector in the systematic form. Systematic form means we have to go for polynomial division. If it is unsystematic form, you could have gone for polynomial multiplication, as you have already seen it earlier when we discussed this cyclic code generation. Now the second part of this exercise is verify whether z of x is given 1 plus x square plus x cube plus x power 4 plus x power 5 plus x power 7 plus x power 9 plus x power 14 is a valid code polynomial or not. Now here it is given as z of x, means it is a received code. Whether it is a code polynomial or earlier it was given as v of x. V of x is the transmitted code. Now that is not a valid code, we have seen that. Here it is given the symbol as z of x, means it is a received code. Whether it is a received code which is a verified code vector or not. If not, then find its syndrome. Now as it is a received code, we have to find its syndrome so as to detect the error and correct the error. In the earlier case, it was not asked to find the syndrome because it was given the symbol as v of x, which meant it was a transmitted code, which was wrong there. Transmitter cannot have error in the beginning itself, right? So in the earlier exercise, it was not asked to find the syndrome. Now in the present exercise, it is asked to find the syndrome because it is given the symbol z of x. Now let us see the solution. Now we have to find x power n minus k into d of x for arriving at a systematic code vector. So x power n minus k into d of x is what? X power 15 minus 7. The given cyclic code is 15 comma 7. So x power n minus k is 15 minus 7 into d of x square plus x cube plus x power 4. X power 15 minus 7 is x power 8. X power 8 into this data vector, we get x power 10 plus x power 11 plus x power 12. Now, using this x power 10 plus x power 11 plus x power 12, we use the same generator polynomial 1 plus x power 4 plus x power 6 plus x power 7 plus x power 8. When we perform the division, we get 1 plus x power 6 plus x power 7. Now, this corresponds to the check bits. So, R of x is, you can see 1 plus x power 6 plus x power 7 means for 1, this 1 is there. And in between x, x square, x cube, x power 4, x power 5, all are absent. So, we write all 5 zeros. X power 6, x power 7 are present. Lastly, we write 1 and 1. That remainder has to contain totally 8 bits now. Because it is 15 comma 7, n minus k is 8. So, we should have 8 bits. Now, we can write this R of x along with d of x in the systematic form. So, the code vector now is 1 0 0 0 0 0 1 1, that is R of x, 8 bits. Then d of x is 0 0 1 1 1 0 0, as I mentioned you earlier. This is now the data vector 7 bits, this is now the check bits 8 bits. Total it is now 8 plus 7 is 15 bits of code that is going to be transmitted, and this is a systematic code. As you can see, the check bits are at the beginning and the data bits are at the ending. Now, coming to the second part, the given z of x, if it is a valid code word, it has to be divisible by g of x. Let us write this z of x, which is given this way, 1 plus x square, like that it goes on till x power 14. We will have to divide this received code word polynomial with the generator polynomial. Now, when we divide, this is the division process, you will have to go through it again on your own. We get the remainder, that is x square plus x power 5. If the received code vector is not having any errors, then we are supposed to get 0 here as remainder. But now we have a non-zero remainder, which means the received code vector is having errors. Now it is asked to find its syndrome. How to find the syndrome? This itself is the syndrome, right? When we perform the division at the receiver, then the remainder of the division at the receiver itself is the syndrome. So, now the remainder is non-zero. The given z of x is not a valid code polynomial. Now, its syndrome is what? S of x equals x square plus x power 5 itself is the syndrome. We can write it in the binary fashion. 0, 0 and 1, x square is present. Then again 0, 0, then x power 5 is present, 1. Next again 0, 0, x power 6, x power 7 are not present there. When they are not present, we have to write them as 0. So, now this is the syndrome vector. Now, the syndrome can be obtained there at the receiver, and through this syndrome, the position of the error can be found out and the error can be corrected. This is now the second exercise. Let us move on to the last exercise of today's class, and the last exercise that is going to be discussed now as part of this teaching learning process. So, in this exercise we can see the generator polynomial of a 15,7 cyclic code is g of x equals 1 plus x power 4 plus x power 6 plus x power 7 plus x power 8. Again a 15,7. As I have told you, expect such exercises even in the test, even in the exam. For that matter, you will have to work out all these exercises again on your own. I will keep on repeating this again and again, hoping that only when we teachers repeat these things with the students, only then they will keep on working out. Otherwise, many times students take the teaching learning process so lightly, thinking that it is all easy. Sometimes students can be overconfident in thinking that they have understood everything. Now, understanding is something, practicing is something else, agreeing for the process is also something else, right? Initially, you will have to agree upon this. I hope all students will agree upon the teachers for the teaching process, right? Because we are going to teach whatever is there in the curriculum only. So, first you have to agree upon the fact, then you have to understand the fact, then you have to practice the fact. These three are three different things, but they are all related. Agreement, comprehension, and practice. These three are related. If at all I tell you some other spiritual sentence for that matter, if at all I tell you, Aham Brahmasmi, Tattvam Asi, Ayamatma Brahma, Prajnanam Brahma. These are called four Mahavakyas in the Veda, four great sentences in the Veda. Aham Brahmasmi, Tattvamasi, Ayamatma Brahma, Prajnanam Brahma, which basically means I am part of the divine, you are also part of the divine, the soul is basically divine, the ultimate knowledge is the knowledge of the divine. That is the meaning in essence of all these four sentences. Now, in the beginning, people may not understand all these four sentences. They may say these are something rubbish, something foolish, or something which is coming out of some stupid brain. Initially, they may think that way. But you should agree these sentences in the beginning, taking respect for the people or the saints or the sages or the seers who have written these sentences in the Veda. Not only for that sake in the Veda, even it in the Bible, even it is in the Quran. In many other languages, only languages are different. Truth is the same everywhere. As Jesus Christ has told, kingdom of God is within. As a Prophet Muhammad has told, Allahu Akbar la ilaha illallah. All that mean the same thing. Even in the Veda it is told, Satyam Jnanam Anantam Brahma. God is truth. God is knowledge. God is infinite. Sarvam Khalvidam Brahma. Everything is indeed divine. It's all told in the scriptures. But for agreeing it, your ego may prevent it. That is what I tell about the attitude. If there is a negative attitude, that attitude will prevent agreeing of these sentences. Now, when you agree, only then you will try to understand. First, you should have an attitude to understand. That is agreement. After agreeing, you will try to understand the sentence. When you understand the sentence, you will have to gradually practice this sentence throughout life. Only then life will also be divine. That is the essence of spiritual teachings. Now, coming back from my spiritual domain back to information theory and coding. Whenever I discuss technology, at times I discuss spirituality also, because they are all related that way. We cannot separate everything from everything else that way, because everything is connected in the universe. And that is evidential now by the findings of the quantum physics, that everything in this universe is actually connected. So that way, spirituality is a intricate part of life as such. So spirituality cannot be away from technology. In the same time, technology cannot be away from spirituality. That is where technology is suffering. More and more technology is supposed to help human beings to live in a better way. But at times, technology itself is causing threat and problem to the human beings, because the people who have developed such technology, they have ignored the spiritual domain of life. Now, in spite of all technologies which we are having, the current pandemic is a situation where nobody is able to help us except the divine. You keep yourself fit and fine by means of regular exercise, keep your body clean, keep your mind clean, and you are basically spiritually clean. If you have body clean, mind clean, soul is already clean. That way, if the memory is clean, No germ will affect you, no disease will affect you. People are yet to understand this. In spite of all the technologies, even now, we don't have solutions for some serious issues of life. For that matter, virus will not be eradicated completely from nature as such. Because virus is what? Virus is a germ which will multiply when it has a favorable condition to multiply. Now, inside the body, if there is no decaying happening, inside the body, if there is a warmth remaining, now any germ cannot multiply inside the body. This is a common sense. If body is kept clean, if blood is kept clean, if breath is kept clean, then health is there generally. For any virus related problems, there are no serious medicines as such. Even for a regular viral fever also, you'll have to wait until the virus subsides on its own. That is why there is a common joke or a common sentence in the medical terminology that if you have a common cold, it will go away in 7 days if you don't take a medicine, and it will go away in 1 week if you take a medicine. Which means both are one and the same. Whether you take a medicine or don't take a medicine, your body has to develop the immunity to fight the common cold virus itself. That immunity will develop only when the body has enough energy, and that energy will be developed only when the glucose in the blood is burnt by the oxygen which you breathe in. So it's a very simple fact that if people keep on doing regular physical exercises, and if they keep their blood clean by consuming healthy food, and then if the blood is clean, if the lungs are warm, then no virus will affect us. That's a common sense. In spite of all the technology, people are yet to learn this spiritual fact. Whatever I told you right now is basically a spiritual fact that people are yet to understand, and they are waiting for a vaccine. Even if a vaccine comes also, problem may not be completely over, because vaccine also will have only a limited time period of working in the body. After a few months, even a vaccine will lose its power. That is also proved in all the vaccines as such. Even the people who had polio vaccine being ingested, later on those children had polio. Even the people who had the chickenpox vaccine being given in the young age itself, or when in the childhood itself, later on they had chickenpox also. Vaccine also has got its own limited period of functionality. Afterwards, vaccine also will not be there in the body permanently. So the only solution is to remain physically clean, mentally clean, and spiritually clean. That way, when the technocrats understand the spiritual domain of life, then human life will become much better. That is why I thought, anyhow, today is the last class. Let me discuss some spiritual concepts also with you. As far as the recording is concerned, today is the last class. That's all. Otherwise, I'll have interaction with you even in the future. Okay, coming back from spiritual domain to technical domain, and technical domain back to information theory and coding. Let us see how to solve this particular exercise. Here the generator polynomial of a 15,7 cyclic code is given. 1 plus x power 4 plus x power 6 plus x power 7 plus x power 8. Now draw the syndrome calculation circuit at the receiver. In the first exercise, we drew the encoder circuit at the transmitter. Now it is asked to draw the syndrome calculation circuit at the receiver. And if z of x is given 1 plus x cube plus x power 6 plus x power 8 plus x power 9 plus x power 11 plus x power 14 is the received code vectors polynomial given. Find its syndrome using the circuit, because we are going to have a syndrome calculation circuit. Now verify the syndrome by the division method. The first exercise was related to the transmitter. Now this last exercise is related to the receiver, where we have to verify the syndrome by the division method. Let us see the solution. Now g of x has to be of the degree 15 minus 7. It is 15,7. So it is g of x has to be the degree 15 minus 7 is equal to 8. It is already there. So g0 is 1 and g1 is 0, g2, g3 are 0, g4 is 1, g5 is 0, g6 is 1, g7 is 1, g8 is 1, as is given here. In the generator polynomial itself, it is indicated. Accordingly, we can have all these coefficients. Now, using these coefficients, let us write the syndrome calculation circuit. That is this now. This is the syndrome calculation circuit at the receiver, where you can see these two AND gates with the two enable signals. Initially, for the given number of clock cycles, the Z of x will be entering into the syndrome calculation circuit. In the next clock cycles, the stored polynomial or the syndrome is going to be taken out of this circuit or the registers. So you can see the output S of x, and for that you have a enable signal separately. We had discussed this circuit earlier when we discussed module 5. So now the given received vector, we can write it in the binary form 110, 100, 10, 11, 01, 001, corresponding to this big polynomial. We have this binary number. Now, the register outputs one by one for the clock cycles now. You can say input 100, 101, 101, 001, 101, that way it goes on. We have totally 15 bits here. At the reset, it is all 00. After that, we have these 15 bits here. When all the 15 bits are input to the system, at the end we have this storage at the register, that is 00111000. And how this answer came, for that you will have to work out these exercises on your own. I keep on repeating this again. So now we have S of x equals x square plus x cube plus x power 4, the three ones here. And then we have, these are anyhow 0, last two are anyhow 0. So this is the syndrome now. Now we have to verify this syndrome vector using the division method. Now to verify the division method, let us divide it. This is the vector given, this is the g of x. When we divide the vector given by g of x, we get this x square plus x cube plus x power 4. That is x square plus x cube plus x power 4. The remainder polynomial is x square plus x cube plus x power 4. That means the syndrome vector is verified as the same one. That way, this exercise is now complete. With this, I am coming to the end of this theoretical discussion of information theory and coding. From the next class onwards, we will not have the recording of these sessions. We will have only interactions with each other in terms of question and answer type only. And I want you to participate in those sessions also in future. And in whatever way I can help you in understanding this subject better and in scoring good marks in the exam, if I am helpful to you, then I will be more happy that way. And you will also be more happy that way. With this, let me conclude today's class. As I have been telling you today about the spiritual part of technology, always have some personal time for introspection, always have some personal time for physical exercise, always have some personal time to live better. Don't develop any bad habits as such. Keep on doing good physical exercises. Keep on consuming Chavanaparasha every day morning before breakfast, along with a little bit amount of ghee, so that this particular wonderful rasayana called Chavanaparasha is going to keep your digestive system clean, and it's going to keep your circulatory system clean. It's going to keep your heart clean. It's going to keep your lungs warm, and it's going to keep your blood clean. That is a wonderful rasayana which was invented millenniums before or centuries before by the great sage called Chavana. So keep on consuming this Chavanaprasha lifelong. You will remain healthy and happy. You will have to keep on doing physical exercises also. You will have to be physically fit, mentally fit, spiritually fit. You should keep your body clean, mind clean, and yourself clean or your soul clean. Keep your memory clean, That is the essence of life. If memory remains clean and pure, we will have a life that is clean and pure. If memory gets infested, memory becomes corrupted. That is when our future depends on our memory itself always. So, with these last wishes, I will wish you all the best for your future, for your exams, for your life. And let me end today's session. Take care and goodbye. Keep in touch.